So this is a homework for the trig identities, and all we're trying to do here is make this look a little simpler. So if you notice, the first four problems are pretty much the same. So I'm just going to pick number 3, and we'll just try to do that one. So I always like to keep things in sine and cosine. If they're not in sine and cosine, I change them. So sine theta, I'm going to go ahead and leave. But I'm thinking about this idea of secant, and I realize that secant's really 1 over cosine theta. So if I multiply two fractions together, remember there's a 1 here, and you typically go straight across. So I'm going to get sine theta over cosine theta, which is just tangent theta. Tangent theta is much simpler than that, so then we turn it into tan theta. So the next 3 above that, 1, 2, and 4, pretty much the same. Let's go ahead and look at number 5. I believe that we just found the trig identity from Pythagorean for the secant squared. Now, do you need to memorize that? Not necessarily, and you should have your notes there. I'm looking at mine. It says secant squared is tangent squared plus 1. So I've got tangent squared theta minus tangent squared theta. And if I go back and look, it's tangent squared theta plus 1. So I'm going to have to distribute that negative sign. What's going to happen to my tangent squared? Well, they're going to go away. So my answer to this is -1. So actually, all the trig functions happen to disappear. Number 8 is very similar to that. I think you already know what 1 plus tangent squared is equal to. Think about your quotient identities. I'm going to work on number 7 because when I look at this, I see 2 items added. I like sine. I always change things into sine and cosine. Cotangent I don't like, so it is cosine theta over sine theta. And I have another cosine theta. So I see cosine squared theta, but if I'm going to add fractions, I need to have a common denominator. So the first fraction has a 1, so I'm going to multiply this by sine theta and sine theta. So I end up saying that I've got sine squared theta plus cosine squared theta all over sine theta. Well, I know that that's 1 over sine theta, which really turns into, let's see, 1 over sine would be the reciprocal identity, which would be cosecant theta. So that's essentially what you're going to be doing. Finding a common denominator is one of the keys that you want to look for doing. If I look at number 10, I'm going to rewrite cotangent into cosine of theta over sine of theta. Can't really do much with that. In the denominator, I have 1 over sine theta minus sine theta. Well, in order for me to subtract these fractions, I need to have a common denominator. And I know that sine squared, or theta times theta is sine squared theta, but if you think back about your first sheet, which hopefully you have in front of you, 1 minus sine squared theta is cosine squared theta. So this denominator turns into cosine squared theta over sine theta, and then the numerator is cosine theta over sine theta. So when you multiply by the reciprocal, that's what division of fractions mean. You keep your first fraction. Division means you multiply by the reciprocal. And if you take a look, wow, look what happens. It turns into 1. So that's essentially what you're doing on all of these pages. I'll give you a hint on number 12. And just think of these as a puzzle. I'm not asking you to get them all correct. But notice if I factor out a cosine, now it's just cosine theta times 1, which is cosine theta. So a couple things you want to do. You want to change everything into a sine and a cosine. You want to find common denominators and then reduce. On number 16, I can see a lot of people canceling those ones. You can't do that. Okay, I'll get this one started for you as well. And let's see, secant is 1 over. I'm going to change everything into sines and cosines. I'd love to do something like that, but I cannot. I need to have a common denominator, which would be cosine over cosine. So now I have 1 plus cosine theta in my numerator, and I have cosine theta plus 1 over cosine in my denominator. When I multiply by the reciprocal, my cosine plus 1s are going to cancel. So I'll be posting the answers to these. Do what you can. Okay, I'm not asking you to get all of these correct. Just think of them as a puzzle, turning them into sine and cosine. I see here there's something that we haven't talked about. That was from the symmetric identities. That secant is the same as 1 over cosine, which we said was even. So essentially, this negative sign actually just disappears because it is an even graph. And now I turn those into sines and cosines and just do a reducing idea with your fractions. Remember, to add fractions, you need a common denominator. Multiply, you go straight across.